Hey guys, welcome to LeetCode problem solving. Today we'll be solving the question 100, same tree. Given the roots of two binary trees P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So basically this is the format of binary tree. We'll have one value, left node and a right node. We have to check if they have same value or not. If they don't, we'll we'll have to return false, and if they do, we have to return true. All right, let's dive right into the solution then. Uh, Let me open the paint. So this is our example over there. These are our pointers. All right. So what I think is we need to compare these. All right. Once we have compared this and they are equal, we'll call a recursive function to check this and this. All right, they have none value down here, all of them. All right, so recursive call over here comes over here. We'll check this with this, they are equal. So we'll check this and this. None is gonna be equal to none, they are equal. We'll terminate, return true over here. If suppose over here another node is there, 4. If this is not none and this is none, then it should return false. Anyways, over here in our case, it's gonna be returning true. Then we'll check this and this will get true again. Then we'll go to this branch. We'll check 3 for 3. It will return true. And this will check for this and this. This will return true as well because there's none over here. And this will return true as well because of none equals to none. Now we have to prepare for this case. For case where the values are different, in which case it will return false simply. And yeah, basically we have 4 cases over here. Let's start coding it. First we'll check if the values are equal. If p dot val equals to q dot val, then we want to return self dot is same tree, recursive call to our function, and to that recursive call we pass p dot left comma q dot left and self dot is same tree p dot right. Both the cases should pass, right? That's why we are doing and logic over here. Now if the values aren't equal, then we simply do return false. Now above these cases we need to check. Okay, we are done for 2 cases. We need to check for the none one. If p is none and q is none, then we simply return true. Now, if it doesn't pass this case, meaning there can be 2 possibilities. One is there is a value over here and over here as well, or there is one value in one of them and other one is none. So we need to check for that. If p is none or q is none, meaning one of them is none, then we return false. And we are all set. 4 of our cases are prepared. Let's run this. We get output for all of them. Let's submit this. Let's submit it again. Oh, 3, 2, 1. Hmm, same runtime. Anyways, that's it for this question. Let's move on to the next one. Symmetric tree. Given the root of a binary tree, check whether it is a mirror of itself that is symmetric around its center. So basically, we start off with this node and we branch off. If root dot left equals to root dot right, is this? It's easy type question again. It's the same logic. This time around, we just have one tree with us. If root dot left equals to root dot right, we check for the remaining one. We return self dot is symmetric. In this function, we need to pass the root, right? Okay, we need to create two branches over here. We need to pass this and this. Over here, it should take two arguments. Let's create a new function then. Is nodes sim self comma left. This is optional tree node comma right. This is optional tree node as well. And this will return a boolean value. Is nodes sim. In this we pass root dot left comma root dot right. है If they are not equal, then we simply return false. Then root dot left comma root dot right. Once we have entered the function, we have passed this and this. It needs to check value for this and pass this and this, and then this and this. Okay. Left dot val Actually, wait a second. Why are we comparing root dot left? This comparison won't work, right? Yeah, this comparison won't work. Is simply we check over here is not none and is not none. This is one case. Another case is, wait, hold up. We need to check for none first, right? Root dot left is none and root dot right is none. Then return true because both of them are none. The other case is if root dot left is none or root dot right is none. In such case, we return false because one of them is having value and other doesn't. And finally, if none of the not they are okay, I have doing my movement. If that isn't the case, then we return self is not sim and it goes in the branch left and right. We need to check the same things over here, just with left and right. Let's go with left node and right node to keep things clear. Now we need to check we have entered here this and this. We need to check if left node dot left, if left node dot left is none and right node dot right is none. If this is none and this is none, then we return true. Hmm, this funda is not quite working. We don't need to return true over here. We need to check for values first. So let's get rid of this logic for a second. If not left node and not right node, then we return true, meaning both of them are null. Now we check for second case. If not left node or not right node, then we return false, meaning one of them is empty, other isn't. Finally, we check for val. If left node dot val equals to right node dot val, then we return. We have to check for this and this. That is self dot is node sim. Left node dot left, comma a write node dot write and the same thing again. This time though, left node dot write dot left. Let's check it now. None and root dot right is none, return true. If root dot left is none or root dot right is none, return false. This is actually unnecessary because we are going for root dot left and checking over here now. So let's get rid of this and simply check if the root is, if not root. Meaning if this is none, not none will become return true. Meaning if it is none, then by there is no tree to check. It's symmetrical. Else we'll do this. Let's run this. Okay, left got capitalized. Is nodes sim. The small typos. Let's run this again. My test cases got accepted. Let's try submitting and see if there is a test case over there which we might fail. No, we didn't. Let's run it again. Hmm, we'll take that. Alright, guys. Thanks for watching, and I'll see you in the next one.